Hey mathletes, here we are going to look at finding the distance from a point to our line. Okay, so in this little diagram here, the distance that we're talking about, so the point we're referring to as D, the line that we're referring to is AB. So we want to find that distance, and so recall that distance is the distance here. Okay, from C to D. Our first example here, we're going to look at on page 89, and to remember how we can determine when lines are parallel, perpendicular, okay, or neither. So if we're given 2 points, okay, remember all this idea of parallel and perpendicular, we need to be thinking of slope. And so we have our slope equation. Y is on top, X is on bottom. Make sure you start at the same point with top and bottom. So, using these two first for L1, let's go ahead and find the slope of line 1. Okay, so I'm going to do 0 minus 2 over 2 minus negative 2. I get negative 2 over 2 plus 2 is 4, reduce it to negative 1/2. So that is the slope. Let's call it M1, negative 1/2. Okay. Next, let's go ahead and find the slope of line 2. Okay. So again, I'm using the same slope equation. Okay. I start with y's on top. Start with the same point. There x's, and we get negative 6 over negative 3. Negatives cancel out, so this is equal to 2. Okay. We notice that these two slopes are opposite reciprocals. Okay, they're flipped and they're negative. To verify that, we can always multiply them together. And it equals negative 1. So therefore, you can make the conclusion that they're perpendicular lines, perpendicular to each other. Okay, so we're going to employ that here on page 90. So on example 7 here, we're finding the distance from point A to Y equals negative 3x minus 5. Okay. So when we're thinking about this, let's go ahead and look at our decimals. Okay, so I went ahead and made sure I went over to my settings and turned on my axes and my grid. Next thing I want to do is I want to graph that point that we're talking about. So in this example 7 on page 90, our point is 0, 5. So I can graph that right there as a point. Next I want to graph my line. I can do it 2 ways. I can use my line tool and graph 2 points, or I can go over here into my equation and just over here type in the equation of my line. So I have y equals negative 3x minus 5. And so that graphs it there. So recall, when we're finding the distance of a point to a line, it needs to be perpendicular. So I need to create that perpendicular line, or find it algebraically. And I'm going to select the point and the line I want it perpendicular to. Okay. From there, I get a new intersection point, E. Okay. And now that I have that intersection point, I can find the distance from B to A point to a line. And I know that's the distance because if I check my angle here, I'm going to need another point. If I measure this angle, it's perpendicular. So let's do this algebraically. So, find the distance from point. So this 4-step method works for any problem. So I'd make sure you have a clear example of this written down so you can duplicate and kind of follow this algorithm. Remember, an algorithm is just a set of instructions, okay, that you follow. Okay, So our point is A, and we are doing it through 0, 5. The line that we're talking about is y equals negative 3x minus 5. I'm going to call this y1 because we're going to deal with another line, the perpendicular line to that as well. So when I'm finding the slope here in step 1 of a line perpendicular to that given line, okay, well, I know that the slope of y1, I'm going to call it m1, okay, is equal to negative 3. My new slope, m2, remember, m2, I want to be perpendicular to m1 because I need that distance to be, that line that we're finding is going to be perpendicular to it. So m2 is that line. So that slope of m2 must be the opposite reciprocal. So now it's positive 1 over 3. Okay. So my new slope is negative 1 over 3. Okay. We have a point, just from above, 0, 5, that line must go through. So we're going to find that equation of that line. Okay. So to write the equation of the line, remember this is for y2, my new line, okay, my slope is opposite reciprocal. Okay, where b is our y-intercept. Okay. I don't know my y-intercept, so I need to find that. But I do know an x, I know a y value right here. I'm going to plug them in, respectively, in their locations. 5 equals 1/3. Love multiplying by 0. And we get 5 equals 1/3 times 0 plus b. This just reduces to 5 equals 0 times anything. 0 plus b is b. So my y-intercept is b. So now, combining the slope and my y-intercept, I have my line that will go through point A and goes through, and is perpendicular to negative 3x minus 5. So next what we want to do is graph these so we can find the intersection. Okay. So remember our first line, y1, was negative 3x minus 5. So I graph kind of backwards. So I do negative 5 first. My y-intercept, negative 3. So it's a downward slope. So since I'm downward, it's a rise of 3 and a run of 1. So I'm there. Up 3 over 1, I'm there. Up 3 over 1, I'm there. Up 3 over 1, I'm there. Okay, I've graphed paper. This is an appropriate time to get it out. Okay, so we can graph y1. Now we have y2, which is our perpendicular line. Okay. So I don't know b, but we know what b is. Okay. So at 5 is my intercept. My slope is 1/3 positive. So I'm there. Up 1 over 3. Up 1 over 3. Up 1 over 3. Okay. I'm there. Okay. This is, in fact, perpendicular because they're opposite reciprocals. My point A, which is here, 5, 0. Okay. Now, so where do they intersect? So this is kind of point B. Okay, this is A. Point B, where do they intersect? We can see here they intersect at negative 3, 4. Okay. So now I need to find the distance from AB. Okay. That's what I wanted to do in the first place. But there's multiple steps we got to do in order to do that. Okay. So our original point, saying just A, okay, which was sorry, it was 0, 5. Okay, and our intersection line is -3, 4. Okay, now we're going to employ our distance formula to find the distance from point A to point B, the original point to my intersecting point. So my distance, again, quick Google search, look at your notes, you find the distance formula. Square root, difference of my x's, 0 minus -3 squared plus difference of my y's, 5 minus 4 squared. Simplify inside my parentheses first. 0 plus 3 is 3 squared. 5 minus 4 is 1. 1 squared. Square root of these still. Next, square both terms. 3 squared is 9. 1 squared is 1. Square root of 9 plus 1 equals the square root of 10. That's my exact answer. If I rounded it and got a decimal, I'd get approximately 3.2 to the nearest tenths place. Notice, I found that same answer and I was able to verify it using GeoGebra here to get 3.2. Okay, that concludes our notes today. Please bring any questions to our class.